Okay, security, chapter 21. So, important concepts here are the encryption, asymmetric encryption, digital signatures, and what that has to do with the digest and hash, digital certificates and certificate authorities, and then we will move on to these two topics in a different slide. So, encryption. Encryption is just one of the information security techniques that, when we are talking about information security, we need to care about many things. One of them is, well, the most common one is to make confidential, right? Oh, confidentiality, which is making sure that the information is given only to those who need to see it, right? And authenticity means that the information is coming from an authentic source, and integrity, that the message is not modified or the information is not modified and it's consistent. That reflects reality. Non-repudiation, which means that if I said that I sent or signed a document, or I sent or digitally signed a document or data, that I cannot take it back, right? If I said it once, then I shouldn't take it back. And availability means that the information is available when I need it. So this has more to do with backups and all that, but the ones we really care about today in this sense is to make things confidential at some point. We care about the authenticity and the integrity and the non-repudiation. That's why we're going to talk about all these concepts today. So encryption is just the process of taking one source of data or information and applying one algorithm to it using a key that produces this is the encryption process, and produces some output that is called the ciphertext. Now, it's not always text, but it should be. And this is just encrypted data, right? And once I encrypt it, it is an encryption process if there is a way to take the ciphertext and apply a decryption algorithm using, it could be the same or a different key, and then I produce the original data, right? So if this is equal to this, then I have an encryption decryption process, right? Now, that's encryption. Now, what's asymmetric? Now, if you use the same key for both operations, encryption and decryption, then you're using symmetric. And that's kind of inconvenient for communications, because that means that if I encrypt text, I need to send anyone who's going to open or read the file or read the information is going to need the same key. So that's a problem. I need a safe way to send keys, and that's kind of a problem, right? If someone gets the key, then done. You have no more confidentiality. So the other approach is to have a asymmetric, or maybe this is double M, asymmetric way of doing things. So what you do is you generate a couple of keys. Key 1, key 2. Now, key 1 and key 2, they're bound in a mathematical way. So if I encrypt something with this key, I can decrypt it using this key, and vice versa. If I encrypt using key 1, I can decrypt using key 2. I think that's an important concept, and some people think that, I don't know, like then we call this private and this public. So if I am going to keep that hidden and this is when I'm going to publish, some people think that only with this I can encrypt. No, that's not the case. I can encrypt using any of those, right? It depends on what I want to do. But the good thing about this is that if I encrypt using this, I can decrypt using the other one, and backwards, all right? So how is that useful? So, well, when we're talking about transmission of information, then it can work in two ways. Let's say that this is the guy A, the guy B, and guy A has his two pair of keys, the private and the public keys, right? So he makes this public key, well, public, right? So anyone who looks this way knows the public key. So the way this works is, if I want someone to send me an message that I want it to be confidential, I just tell them, look, just take a look at my public key, use the encryption algorithm that I tell you, and then you can send me your message back encrypted. And since these two keys are bound together, I can decrypt it using my private key. All right, that's one way. So I keep my private key private, and the public key, I share it with anyone who wants to send me information. And since they two are connected, then this person can send me messages that only I can read. Okay? That's one way to use it. Now, what happens if that's not the case? I just want to send information, and I mean, if I want to send information to B that is confidential, well, I use the same process, right? I just take this B public key, right? This is A. I take B's public key, and then I use the algorithm, and I'm encrypted, and I send it to him. And obviously he's going to use his private key to decrypt, so only him is going to be able to open that file or that information. So that's if I want to send information that is confidential, right? But what if I just want to send information to him, and I want him to be sure that I sent it? So that's when we talk about these graphics that we have here. Let me just move this a little bit. And this is when we talk about first digital signature. So a digital signature is making use of the fact that those two keys work together. So if I want to make sure that that the message that I send, let's say that I am A, right? And this is B. So B, I'm going to send something to B, and I want B to be sure that I was the one who sent it. So if I publish my public key, right? My public key, wait. This is A's public key, right? And I encrypt something using my private key. So I take my private key. What? And I encrypt this information. Then when he gets the information, all the information that is encrypted, and if he uses my public key to decrypt it and he gets the message, then he knows that the only way that he could have decrypted it is because he used the corresponding private. So if he knows that this is my public key, then the only way I could have sent that information is because I had the private one. So who has the private one? Well, A, right? Private one for A, only A has it. So he could be sure that that message was sent by this guy. Now, obviously, you would say, oh, but if I can decrypt using the public key, then anyone can because it's public. Well, yeah. I mean, in this case, I don't care if the message that is being sent to me is confidential. We already know how to make confidential things, right? We just use the private and send it. So here what I'm doing is not that. I just want to make sure that this guy believes what I'm saying. So what I send is both the message, like hello, how are you? That's not going to be encrypted. It doesn't have to be, because I don't care that this is confidential. If I cared, I would use the other method. But since I don't care here, then what I'm doing is I'm digitally signing it by creating the encryption file using my private key. That's signing it. That's signing it because I use my private key, right? And so anyone knows that if they use my public key, then they can decrypt it. So that's a signature, because that makes somehow proves that it was me who encrypted it, right? That's the way it is. But there is one little thing with that. I mean, if it's not like a completely safe way, because I want to make sure that the message, as a receiver, I want to ensure that this message corresponds to this this encryption, right? So one thing they do is this. They use one hashing algorithm, and what a hash does is, out of a particular message, it creates a unique digest. So if I use, for example, hello here, and I use this algorithm, the digest I get, let's say, I don't know, let's say that this is the digest. If I change this just to, for example, say hello and then one space here after the dot, this digest would change completely. So that the digest is making sure that there is a unique correspondence between the original message and the output in the digest, right? So if I change something here, it's going to change the digest. So I can be sure, if I have one digest, I can be sure that if I have the original message, I can be sure that that was not changed. So when I am going to send the message to this guy, I'm going to send both the message and the encrypted or the digital signature that we just talked about, which is an encryption using my private key, so anyone with the public key can decrypt it. So that's the digital signature, and this is the original message. So if I send both, right, I can help my receiver to make sure that the message that I send is mine and it's not modified. So how do I do it? I just take the message. I use a hashing algorithm that creates a digest. That's the way the result of this algorithm is called, a digest. And then I can encrypt it using my private key, right? And that's my digital signature. The complete package is the digital signature. Well, this is one approach to the digital signature. This is a better approach when I use the digest. So in the end, digital signature means that I use an encryption algorithm using my private key, right? That's the digital signature. And then when the person this is B receiving the information. Well, he gets two things, right? He gets the message and he gets the digital signature. So what he does is he's going to compare the two results. So he's going to apply the same hash algorithm because this algorithm is public. It's something I didn't mention. So these two guys, this cryptographic hash algorithm in here, they are the same. It's the same algorithm and it's public. Doesn't matter if I know the algorithm. And actually it should be agreed on so we can verify things. And so since it's the same, if I take the same text and I get the same digest as the one that I get when I decrypt the signature, if these two correspond, then I am sure that the message that he sent originally is the same, and with the digital signature I know that, well, this came from A. All right, and I can decrypt that only using this guy's public key, right? If I can decrypt it using the public key, then I know it was him. This is A. All right, this is A who sent it, I mean. All right, so that's one thing that we can solve. I mean, now I know that this we have integrity, right? Just go back to this integrity, and because we know that the message was not modified because we have a digest and we checked it with the encryption one, and we also have that authenticity, right? Now, yeah, we know that whomever made this public key was the one who encrypted it. Now, we know that there is a correspondence between those two, but how do we know that that public key is actually A's public key? Or that, you know, that no one else is using a public key in the name of A? That's when these guys come, the certification authorities. So what they do, they do basically the same thing. They just use it to make public the information that they have found about the person that is saying or that is using the public key. So if this is the guy A, right? Let's say that he wants everyone to be sure that his public key is his. So the thing that he does is he takes his public key and sends it to a certification authority, yeah, like VeriSign, or I don't know, any of those big companies that made a lot of money out of this. So they what they do is, okay, they say, look, I'm gonna take your information, I'm gonna check first that your name is correct and that you're who you say you are and that you live where you say you live, right? And that's your website, for example, and that's your IP address, and all sorts of, I mean, the information that I really want to check, if it's a website or if it's any type of certificate that I want to provide, right? So I take all that information. Then I also take the public key that he sent, right? Which is a bunch of, you know, characters there. And then I take this information and using, I mean, if I am the certificate authority, what I do is I take my private key and I encrypt all this information, right? So I have a private key and I also have a public key, right? So anyone, if I make this information public, anyone who has the certificate authority's public key can decrypt this information, right? And they're going to be sure that it was me. It was the certificate authority, the one who issued this certificate. Now someone would say, but we have the same problem. I mean, I could say that I'm a certificate authority and then do the same thing. Well, yeah, that's a problem. And They have their own certificate authorities, these guys. Now, these guys are known all across the internet, right? These are the real big daddies of authorization. So that means that you shouldn't worry if they say something, you should believe it. That's what the software does. If I am using a web browser, they have a way to verify that these guys are who they are, and if they say that these certificate authorities are okay, then the browser or any application that uses this type of security believes it. All right. So what they do, look, this complete thing, the encrypted thing, is called a digital certificate, and this is sent back to A, so he can use that for any communication. And whenever he's going to send, for example, a message to B, then he attaches to the message, he attaches his digital certificate, which has been validated by these guys and the guys who validate them and all that. All right. He can even use that certificate to use it in his website, so you can have an HTTPS type of transmission, right? When you go to your bank, then you see this in your web browser, right? You see a lock there. If you don't see the lock, please do not put your money there, because that means that there is no certificate. So this means that, oh, the browser somehow checked that they say they are who they say they are. So if this says that this is Construction Bank, then it is Construction Bank. It's not some hacker trying to get your money. All right. I think that explains a little bit the concept. Yeah. And so we explained what's encryption, asymmetric, what's a digital signature, what's a digest, which is the process of using a hashing algorithm, right? And we know now what a digital certificate is, which is just signing something with encrypting with my private, so anyone with the public knows that I did it. And the certificate authorities that just provide a way to know that my public is my public. Okay, we're gonna work on these two in the next two slides. So I hope it's clear. If it's not, please send me an email or a WeChat message. Now, SSL and TLS are two protocols that aim to achieve security in the transmission of information across the networks and the internet. And the acronyms mean SSL means SSL means secure socket layer, and we're gonna see what that means. And TLS means transport layer security. These are a bunch of protocols. These are two protocols, or a suite of protocols, that are used to make communications more secure. Now, what is a socket? A socket is just a combination of an IP address and a port that has or determines what kind of service we're looking for. So if I send to my IP address, or to a server's address, and I used 8080, this port is saying what's the type of application or service that I want to access in this particular computer, or the computer that is identified with this IP. So secure, so we know now what socket is. So it's just communication between two computers for a specific application, but we want to make those secure. And that layer of software, it's meaning that there are many protocols. It's just SSL is just not just one. It's a bunch of protocols that we use for that. So that's why it's called a layer. So it's a group of protocols that are used to make the communications using sockets secure. This was the first version. Now this is a more secure version of SSL. So the protocols were changed to make them more secure, and now it's called the complete transport layer security. So it's trying to make all the transport of packages more secure through the internet or the networks. So um, we already know what digital certificates are, and those are what make the secure part of the SSL or TLS. We also have encryption using session keys, which are symmetric type of key, and we're going to see how that works. And it's also based on the digital certificates. I mean, the communication is using these two aspects of secure communications: digital certificates and the encryption of using session keys. Now, in one of the videos that I have provided you in the chapter reviews, they explain that there's a little problem between these two types of models to describe this layer of software. So in the TCP model, you would say that the SSL and TLS corresponds to this application layer, and it's serving transport. So this is just like saying that it's preparing the information to transport, and it's also taking the information from transport to application in a secure manner. So it's the information that is coming to application is secure. And but in the ISO model, in the OSI model, not ISO. In this model, there are three layers, and you shouldn't associate this protocol to a particular layer of this, because it is a protocol, so it's identified by one of the application layer softwares. I mean, there should be part of software in the application layer that handles the information being used by SSL and TLS. So it's part of application. Yeah, the presentation layer is the layer that presents information or data prepared to the application layer, and usually the encryption algorithms and the compression algorithms are part of this layer. So this also is part of the SSL and TLS. So it could be said that is also part of presentation. And the session layer, since we define a handshake, and we also define a session key and a session ID, then we could say that we're talking about the session, and so all that is true. So the SSL and TLS belongs to any of those layers, right? So when you're describing the way this works, you could start explaining how it goes from one layer to another. If we're talking about OSI model, if we're talking about TCP model, then it's just application, and then you can explain these different things that it does. So what does it really do and how does it work? So let's say that I am trying to access a website, so I request I don't know, www.baidu.com, right? Well, there is no dot in the www. So or I don't know, Bilibili, whatever. I think that's the way you write it, I'm not sure. So when I use this URL, then I am looking, I go and ask the DNS server, right? And the DNS returns with an IP address. Oh, well, it should be a different number. And then when I get the address and I see that there's a connection with using the IP, I find this guy. Then I send packages. The first package that I send is the hello package, which is containing a lot of information. So when I say hello to a URL, then if the URL is specifying the HTTPS, right, then what I'm doing is I'm requesting a certificate, and I am sending information about the protocols that I can use and the algorithms that I can use to communicate. What type of algorithms? I mean, like what kind of cryptographic algorithm I'm going to use and what type of data compression I'm going to use, data compression algorithm, and the SSL version that I'm using, because there are different versions, or the TLS version that I'm using. And that's the hello message. That's like saying, hey, I want you to communicate with me using HTTPS. So when the server answers back, it's going to send me, if it's an HTTPS, it should be able to send me its certificate, right? Because there is no way you can get an use HTTPS as a server if you don't have a certificate. So in that certificate, as you know, we have the public key, right? And it also replies saying, okay, from the list you gave me, I'm going to use these protocols and I'm going to use these algorithms for compression and for encryption. So once I get that information, so I know now what compression and encryption algorithms I use, and I also know what's the certificate, then I'm going to check with the CA, the certificate authority, if the public key that I got, it's the same that they have registered, right? I just go there and decrypt the certificate using their public key, and I check that the one I got in the that I decrypted from the certificate is the same that I get sent by the server. So when I have that, if I have compared and I have that, now I know that the public key corresponds to that website. So I'm sure that that guy's public key is valid. So I use that public key to encrypt the information, and I send my shared secret session key. Now this key is used in symmetric because this key is the same key that is going to be used by the server to send me information. So since I already have a public key from the server, I can encrypt that information, and only the server is going to know what's this session key, right? Because it's a secret message. So once that happens, the server is going to confirm that, is going to send me the confirmation, the handshake confirmation using an encryption. So every message that the server is going to send me from now on is going to be encrypted. So using that session key is going to confirm the handshake, and it's going to use for that the shared secret key, which is the same. So that's basically how it works using TLS or SSL. So just to summarize, we have a hello, then we confirm the certificate and the public key, and using the public key I send a symmetric key, which is then used for every single communication in the session with the session and the session ID. Oh, I forgot to say that. We have a session ID here, right? There is a number that identifies my session with that computer, so the server knows which computer has a session already with that server. And that's when you say, when you lose session, that means that your secret key is not valid anymore, so you cannot start sending and receiving information that is secret. All right. So another thing that you should know is that when you have an HTTPS, you have this little lock there that makes this valid, right, in your web browser. Okay, I think that's it for SSL and TLS. Then let's just talk about malware. And last but not least, malware. So, of course, if we talk about security, we should talk about the threats to that security. So, the uh, mm, threat that we talk about here is the software that is created to compromise the information security in computer information systems. So they attempt to tamper with the confidentiality, authenticity, integrity, or availability of information. So what are these types of programs? Well, we have the virus. The virus is malicious software that is meant to do horrible things in the computer, and the main feature it has is that it is attached to an executable file in order to be executed and replicated. So once the executable file that is the host for the virus is executed, then the virus starts executing and replicating itself. The worm, that's one of the main differences. It runs independently, so it doesn't need an executable file, and it uses the network connections to replicate from one system to another. So I mean, these are not exclusive. So you could have a software that is both a virus and a worm. So meaning that you could attach it to an executable file, and then this file would be replicated to a computer that it starts using the network to replicate. So it could be something like in between those two. And a logic bump is just a program that starts doing the harm once a condition is met. So I don't know, if we have reached the 2000 day, then there could be the 3000, the year. Well, this was actually a real situation when the year 2000 there were some viruses that were created. So when the year changed, they will start tampering with other systems. Now I don't know, we might have a 3000 version, hope not. Now the Trojan horse is just a program that replaces part of a program. So it's like the story, you just installed your program, and you didn't know that inside that program there was part of malicious code. So when you execute it, then that part of the program is also executed and starts harming. Now the difference with the virus is that this is not replicated, or it might. I don't know. Spyware. It's software that is meant to take information from your computer and send it to another computing system. So it could be checking your information files, or maybe your camera or your microphone, and sending it to someone else. So very dangerous thing. And the bot is just a computer program that takes control of your computer. For example, it makes your mouse go crazy or starts typing things that you're not typing. That's called a bot. So there are activities related with this. Phishing is one of them, which is sending emails to very naive people that sometimes they just open them and start looking for them, and then they say that they just want $1 million, and they just need to provide the credit card so they can deposit or something like that. So when they start asking for information that is confidential, that's called phishing. They usually use mail or chats, could be. And farming is just on demand. So they just create a fake website. I don't know, like instead of Bilibili is Billy with double L. I don't know. So if you typed it this way, then you have a site that is pretending to be the original one, and they start I don't know, gathering information from you using maybe the cookies in your web browser, and start once you visit the site, then they just establish a connection with your computer, and they might start doing things like sending malware or just trying to get information from you. And so if you send your credit card to one of these sites, then they're gonna have it, and it's not gonna be a secure site, right? And the other one activity is providing users with keyloggers, which um, is software. This should be actually here. Software that is created so whatever you type in your computer is saved in a file and then is sent to another system. So the activity could be related to doing that, to using keylogging so they can get your passwords. What can you do against this evil people? Well, you can install antiviruses and maybe in your network define a firewall. Um, you can provide your email with filters so you can avoid spam or start sending unknown senders to a specific folder and checking them later. Uh, Updating your software like operating system and programs so they can get rid of the bugs that they have and the security issues that they have, and save activities in the web. That means mm, visiting for example HTTPS websites that have security, and also to be informed of what are the types of malware and situations like phishing and farming that could get you into trouble. All right, I think that's it. It was a very long video. I hope you guys don't fall asleep, and I'll see you in the next. I think this is the last for this week, so next week. Take care. Bye bye.